Everyone, welcome to Dotnet. So, in this question, there is a charge small q that is placed at the center of the line joining the two equal charges capital Q, and it is given that the system of the three charges will be in equilibrium if a small q is equals to, and we have four options: q upon 2, minus q upon 2, q upon 4, and minus q upon 4. Okay, so suppose this is charge capital Q and this is charge capital Q, and in between them this is charge a small q. Okay, as you can see, this a small q charge will experience electrostatic force from both the charges capital Q. Okay, so a small q will already be in equilibrium. So all the system, so the whole system will be in equilibrium in case if any of the capital Q is in equilibrium. So suppose this distance is, let's say this distance is small r, and this whole distance is 2r. Okay, then if suppose this capital Q charge is in equilibrium, then the whole system will be remain in equilibrium. Okay, so the force on this capital Q, because of this capital Q, will be like this. Let's say F Q. Okay, and because of this small q, there should be a you can say there should be a attracting force, okay, in this direction to balance the force of capital Q. So let's say this as F small q. Okay, so since this distance is also r, will equate F capital Q should be equals to F small q. Okay, so F capital Q will be what? F capital Q will be K into this Q into this Q, that is Q square upon the net distance is 2r, so its square will be 4r square, will be equals to, now look, the value of a small q will be in the opposite nature of the capital Q. That is, if capital Q is positive, then a small q should be negative, because the nature of force between both the charges, that is small q and capital Q, is attractive. Okay, so you can say that you can write it as minus of k into a small q capital Q upon, you can say it as r square, since the distance between these two charges small q and capital Q is small r. Okay, now you can cancel this k and k, okay, and r square and r square, and you'll get a small q equals to capital Q upon 4 with a negative sign. Okay, so among these options you will get option 4, that is minus q upon 4, as the correct answer. So this option 4 is the correct answer here. That's all for this question, guys. Thank you.
The given question is two equal negative charges minus q are fixed at points 0, comma minus a and 0, comma a on y-axis. A positive charge plus q is released from rest at point 2a, comma 0 on the x-axis. The charge q will, so these are the options A, B, C and D. Okay, so let me draw the figure first. We have, let's say we are having axis like this. Okay, so on the axis, two minus q charges. So one is placed at 0, comma a. Okay, this is minus q charge. Another is also at 0, comma minus a. So this is minus q, and another charge plus q is placed at 2a, comma 0. Okay, so somewhat here, this is plus q charge. Let me draw this. Okay, so this is positive x-axis. This is positive y-axis. Okay, so now in the option 1, we have to check whether this charge q will execute simple harmonic motion about origin. Okay, so let's check about whether this charge is performing SHM or not. And before that, let's check what are the forces acting on this charge plus q. So let's take this distance between the y-axis and q charge be x. Okay, although its position is given as 2a, but first of all, for SHM, we have to check whether force is proportional to minus x or not. Okay, minus x, so let's say x. So if this is the primary condition for SHM, let's check that. So the force acting on charge q due to minus q charge will be an attractive force. Okay, in this direction it will be happening, right? So we can say a force Fr is acting like this, and similarly we will have a force due to minus q charge, also the same force, that will be Fr. Why same force? Because we note that electrostatic force is given as K Q1 Q2 divided by R square. Okay, where R is the distance between the charges Q1 and Q2. So here charges are same and the distance between them. Okay, let's name the points. This is A, B and C. So AB distance is equal to AC distance. So R, Q1 and Q2 are same. Thus the force between the charges capital Q and minus Q will be same. Further, let's resolve this force components in two parts. We will have one will be let this angle be theta. If this angle is theta, this angle will also be theta, and this will be Fr sine theta, right? And in the downward direction, we will have due to minus q charge, this will be same force but in the negative direction. This will be Fr sine theta. Moreover, this force Fr, its horizontal component will be okay. So the horizontal component would be like this. Okay, so this will be Fr cos theta, and due to the this Fr below 1, it will be same. Okay, same force will be acting, that is again Fr cos theta. So this Fr sin theta, the vertical components will cancel out each other as they are in opposite direction. So the net force acting on the plus q charge would be given as, let's say, F net, and this will be equals to 2 times of Fr cos theta, and this will be occurring in the direction of minus I cap, okay, towards the origin, and this will be given as 2 into the magnitude of Fr will be what, K into Q1, that is capital Q, into Q2, that is small q, divided by distance whole square. Okay, so distance between capital Q and minus q is AB. So this is AB whole square multiply by the value of cos theta would be, cos theta will be given as this x over AB, right? X divided by AB. Further, on solving this, we will get 2 into K Q into Q. Okay, AB we can find. See, this distance is A, right? So AB will be equals to under the root A square plus X square whole square multiply by X over under the root A square plus X square. From here, we can write the value of F net equal to 2 times K Q into X divided by A square plus X square whole to the power 3 by 2. Okay, so this will be the magnitude of the F net force. So from here, we can see that F net is not directly proportional to X, okay, which is the prime condition for SHM. So here X in the numerator also and in the denominator also, hence this is not a SHM. Okay, so from the given option, option A will be wrong because it's saying that it's executing SHM. So option A is wrong, option B will be wrong as it is saying move to infinity. Now let's check other options. We will have, see, this plus q charge would be moving towards the origin. So when the charge plus q will reach the origin, the net force on the charge q will be 0 because minus q and minus q both will be exerting the same force in opposite direction. So it will cancel out and net force becomes 0 at the origin. But at origin, this plus q charge will gain some velocity and its velocity will be maximum at the origin. So due to momentum, this plus q charge will move further, okay, in the negative x direction, and it will reach up to a certain distance that will be again equals to 2a, okay, after which the force acting will reverse in this direction and the velocity of this charge becomes 0, so such that this charge will move again in the opposite direction. So in this way it will be performing an oscillatory motion about the origin. So we can say that from the given options, option C would be the correct answer. Okay, because the charge q will perform an oscillatory motion but not SHM. Okay, and this will be about origin. Okay, if I take origin as O, so about origin it will perform a oscillatory motion. Thank you.
Hello, we are given with the question, and the question says for A equals to 0, the value of D, maximum value of P is shown in the figure is how much? So value of D is how much? The maximum value of the density, right? So let us take a spherical shell here, first of all, and let us assume that the total charge simply given by density over the volume, right? So we will take a shell from the center at a distance x and the thickness is dx, let's say. So the charge on that is equal to 4 pi x square rho x into dx. That would be the amount of total charge on that shell of thickness dx. So integrating from 0 to r, we would get the total amount of charge, that is 4 pi x square rho of x dx. Now, if the density distribution here is linearly, right, is given in the figure for A equals to 0, here A equals to 0, then the density would linearly decrease from D at R equals to 0 to R equal to R. The mathematical equation would be given by rho of x equals minus D by R into x plus D, right? So putting this in the above equation, we get Q equals 4 pi D by R, integration from 0 to R, x square into minus x plus D. Instead of here D, we would have R minus x plus R into dx. Or we can write 4 pi D by R. When we integrate this value, it would be minus R power 4 by 4 plus R power 4 by 3. So that is equal to 4 pi dr cube by 12. That is pi dr cube by 3. Right? So given that as given Q is equal to ZE, so ZE is equal to pi dr cube by 3, which implies that D is equal to 3ZE by pi r cube. So our answer would be 3ZE by pi r cube. That is option B. Thank you.